There's a level of like kind of thinness to capabilities development, which is like, someone might think like, oh, let's just grab off the shelf ASR, no modification, no further training. Let's just grab like a backbone model, like, Whisper or something, chain it together with like a simple call to like GPT. The problem there is that, am I allowed to say shits to bed? On medical speech. You find these systems, for example, they transcribe Ozempic as Olympic. There's like 500 different ways to misspell Mounjaro. On top of that, we also face like kind of wild kind of conditions in which we need to process speech. We need to deal with noisy medical settings like emergency rooms. There's a lot of chattering, there's a lot of beeping. We've got weird multilingual settings. So right now we certify our performance in 28 languages. We certainly work kind of like building on the foundation of the best open source tools and what the research community has given us in terms of ideas. But we've had to make tremendous strides in terms of multilingual capabilities, handling noise conditions, and being able to dynamically adapt models to like new and evolving vocabulary, often like at the bleeding edge of, or even in advance of words entering the lexicon.
Zach, it's so great to see you as always, especially in sunny San Francisco now. Last time we hung out was in NeurIPS, which is actually a little while ago. And in addition to your CMU professorship, you're also CTO and CSO of Abridge. How would you explain, when you're in the groups that we often are with fellow academics, what Abridge does?
Yeah, I think there's a few different lines of attack. The original pitch for Abridge was actually, I think it was SoundCloud meets Rap Genius for healthcare. Maybe like narrowest aperture, just focusing on documentation piece, is right now doctors spend about 2 hours doing clerical work for every 1 hour of patient care. So if you think about like what ideally would a health system look like, I think it would mostly be people taking care of patients. Like that's what a hospital system should be doing. And instead you're in a situation where you have a whole bunch of people who are the people qualified to take care of patients, and they're spending 2/3 of their time doing paperwork and 1/3 of their time on direct patient care. And that's like on their clinical days. A lot of the doctors are like part clinical, part research, part clinical, part academic. And that's not counting the fact that like, in addition to that clerical work, you have a whole bunch of other people whose only job is to do clerical work. So you have like the non-medical personnel who are fully doing administrative tasks, and you have your medical personnel who really like, they got into medicine because they wanted to take care of patients, and instead they're taking care of paper. And the question is sort of like, well, like, what are you going to do about it? Like, we're not going to go back to like once upon a time, system was simpler, a lot less was documented. We also had like, we were keeping medical records on dead trees. Systems weren't interoperable. We didn't do any of these important things that are probably really important and we should be doing, like documenting informed consent. And so we want to have our cake and eat it. We want to have digital documentation. We want to capture all the key pieces of structured data. We want to have neatly typed, after visit instructions for our patients. We want to do all this work, and also we want doctors to see more patients. Yeah, so you want like these like four pages of documentation, a tons of structured data entry, and you also want a doctor to be able to like see a patient in like 15 minutes. So it just doesn't add up. And what sort of happened is we've gotten into this world where, by virtue of piling so much administrative work onto our doctors, we've actually kind of created a very bad experience for patients. So a lot of patients, their experience of seeing a doctor now is like the doctor sitting with their back to them, typing against the wall. And it's also a bad experience for doctors. We've entered a world where there's a tremendous amount of churn in the health system. Even if every single person who was admitted to medical school graduated and became a doctor, we'd still have a shortfall relative to demand for healthcare. We wouldn't have enough doctors to provide the healthcare, just because we wouldn't be keeping up with the amount of people that are exiting the profession.
Yep.
And then on top of that, when you actually take surveys of students these days and say, what fraction of medical graduates actually intend to practice medicine, or with what fraction of their time they intend to practice medicine, these numbers are plummeting.
Interesting. So it's not just that they enter the field and churn. It's like they go in with an intention of actually not doing it in the long.
Yeah, and I don't remember the exact number, but it's something alarming. It's something like half of all like medical graduates don't actually intend to practice medicine long time. Um, so like this is a kind of problem, I think technology could play a couple of roles here. Like technology could take doctors away from patients by creating kind of like sort of like more work for us, or it could like kind of bring folks closer together by making a lot of that administrative work sort of disappear or kind of, happen in the background. Key insight at Abridge was that healthcare is all about conversations. Like the meat and potatoes of healthcare is in interaction. Mostly, there's some amount of physical interaction in the context of physical exam, but most of the exchange between doctor and patient is spoken dialogue. And that, kind of like if you were just a fly on the wall sitting in the room, like in a very intelligent fly, metaphor is breaking down.
A fly who can take notes, etc.
Say a really smart medical student. Like you'd be able to, maybe you don't have telepathy, so you can't capture every single thing that's in a doctor's mind. But if you had a really good, kind of synergy with that doctor, you could probably get maybe 95% of the way there. You'd be able to take notes. You'd be able to take a really lucid history. You'd be able to document an assessment and plan. You'd be able to write the names and organize the problems in a perfect way that was clinically useful, but aligned with all of those like downstream billing and clerical processes. You'd be able to pull out all those action items and, kind of like care goals and put together a set of after visit instructions for the patient. Like all these things that like you could do mostly based on the conversation. And certainly you can get even further based on some combination of what's spoken in the dialogue and what's already documented from sort of prior context, previous notes, problem list, patient metadata, care setting metadata, provider metadata. So that was like the key insight of Abridge was basically, hey, if we could only be inside the conversation, listening to the raw audio and plugged into the health system, so we could pull that prior context, that we could actually like AI, could transform all of that into all those key pieces of like, documentation artifacts that doctors need. Their notes, their orders, the patient-facing instructions, prior authorization documentation, referral letters, like all of this kind of stuff is downstream of mostly of what's spoken there or what's spoken there together with this context. And, in 2018, when the company was founded, you could see the trends. The burnout crisis was cresting. You could see the shape of like, hey, like a sufficiently intelligent, system could do this, but the AI wasn't quite there yet. At the time, 2018, we were talking about models that were mostly working with like 256, maybe 512 tokens of context. You're looking at conversations that are thousands of tokens long, sometimes, tens of thousands of tokens long. There was a little bit of a mismatch of where technology was, but the trajectories all lined up. And so that insight was that, hey, we could, and already there was a market for it. Some doctors were willing to spend, some systems were willing to spend not, this wasn't a democratized system. It was more like for the very privileged doctors, like specialists who were making, very high six figures or millions of dollars. They were willing to spend tens of thousands of dollars per doctor per year to have like a dedicated outsourced scribe who would literally do that, would be listening to the conversation and maybe 24 or 48 hours later would be able to like, remit, return a set of drafted documents. So what we've built is basically a system that does just that. It's ambient listening. Doctor records the conversation with the patient. The system captures that raw audio, is able to suck context out of the EHR, and is able to draft, basically put together a first draft of the notes, the orders, the codes, all those key documentation artifacts. So that the doctor goes from sort of like blank slate having to write this stuff over the course of like 20, 30 minutes or at home in their pajamas at the end of the night to sort of having to more be in a kind of editorial position. They have to, revise, quickly read, review, revise, and confirm the documentation. And we've gotten to the point where we're doing it well enough that we're actually improving the documents that doctors are creating.
Well, first of all, that's awesome. And it's a really helpful overview, including all the technology trends and all the medical tailwinds that make this the right time for a company like Abridge. I'm curious to learn a little bit more about how do you get this ambient listening or this really, really smart fly on the wall to be smarter? And so folks talk about ASR and speech to text often. What does Abridge do that goes beyond what general models that you can get out of the box do?
Yeah. So I think first of all, like the shared resources of the community, both in the form of foundation models of open source technology, have always been like I think there's a tendency of people to like want to overstate proprietariness or like to completely downplay like the extent to which the entire community is built on shared resources. And it's like this is something that has been true from the moment of shared architectures, shared libraries, yeah, and something we're big believers in. But if you there's a level of like kind of thinness to capabilities development, which is like, someone might think like, oh, let's just grab off the shelf ASR, no modification, no further training. Let's just grab like a backbone model like, Whisper or something, chain it together with like a simple call to like GPT. The problem there is that, first of all, the things you'd find when you try to chain together a system like that is, first of all, the speech, like in general, we've had incredible progress in speech, something to celebrate. Like Whisper is a better speech recognition system than anything that anyone had 5 years ago. So that's wonderful. It also, am I allowed to say shits to bed on medical speech, as we'll find out. Like you find these systems, for example, they transcribe Ozempic as Olympic. There's like 500 different ways to misspell Munjaro. So like medical speech is it's got like a sort of very long tail, specialized vocabulary. It occurs, often in medical conversations, very maybe, a lot of words, like everyone talks about Ozempic everywhere now, but a lot of it is new and evolving. A lot of words also that, occur often in medical speech, very rarely in common speech, and the kinds of corpora like YouTube conversations, on which kind of like open source models are trained. So on top of that, we also face like kind of wild kind of conditions in which we need to process speech. We need to deal with noisy medical settings like emergency rooms. There's a lot of chattering. There's a lot of beeping. People might have a phone that's recording a conversation. It might be on a desk. It might be on the other side of the room. It might be in their pocket. We've got weird multilingual settings. So we need to handle speech from, right now we certify our performance in 28 languages. And it's not just that there's 28 languages that might be spoken. You also don't have advance notice of which language is going to be spoken. And there's all kinds of wild settings because there might be multiple parties in the room. There might be people code switching, like a doctor speaks a little Spanish, but not that much.
Nature is also challenging, right? You have the mother, the father, the daughter all in the room.
Absolutely. So just on the speech side, we've had to basically, we certainly work kind of like building on the foundation of the best open source tools and what the research community has given us in terms of ideas. But we've had to make tremendous strides in terms of multilingual capabilities, handling noise conditions, and being able to dynamically adapt models to like new and evolving vocabulary, often like at the bleeding edge of, or even in advance of words entering the lexicon. And so we have a lot of strategies that we use to deal with this. We have a lightning fast language identification process that happens like even before we begin transcription. So we're able to kind of like think of it as like setting your priors. You ever had that experience where like you hear someone's...
Well, think of it as Google Translate when you copy paste and you don't know what language it is, and it tells you.
Yeah, well, or I'd say like you ever had that experience where like someone speaks a language and you're not expecting them to be speaking in that language. And at first you're like, what the hell are they saying? And then you have that moment of like, oh, like, this like, in my case, I don't know, it's like this random Jewish guy is trying to speak Chinese or something. And then you're like, oh, okay, now that I know that you're trying to speak Chinese, I know what you're saying.
Well, not the last part for me, but yes.
Yeah. Or I don't, yeah. So there's this process of kind of like setting your priors. And so we've kind of innovated on like, that's just like one example. There's examples of like how we, make our models robust to noise conditions, to polyglot conversations, how we introduce vocabulary, often in the form of like kind of like engineered synthetic conversations that get words into the vocabulary even before they're showing up in organic conversations. So we're able to like, kind of crawl in advance of like, what are new medications being approved? How are they pronounced?
What do we predict is going to enter the medical lexicon before it does?
Yeah. And we know, because we know, for example, what are like new drugs that are approved by the FDA. And we're able to like now pull out drugs. What are the drugs? What are they approved for? So the model, like if a model has never seen a word before, it's got like zero prior that this is going to show up in the output vocabulary.
How is that then incorporated into the models, Zach? Are you like fine tuning the model on this new new data.
Yeah, so there's a massive training apparatus. There's training algorithms, and kind of like data augmentation strategies for dealing with noise conditions, for simulating polyglot conversations. There's ways that we introduce synthetic data that are able to like kind of prime models to have like a non-zero prior for like, kind of like novel vocabulary. There's a whole kind of family of techniques, and we have like a very, you know, strong but lean team that like is really single streamed on our speech technology that has advanced these models. So like that was like one huge thing, getting and that's all just the level of like faithful capture of the transcript. Then there's like everything that goes downstream. Like when you're documenting, how do you know that you need to document in a way? It's not enough to produce something that like to a commoner would look like, okay, yeah, I could see how that's a summary of the conversation. You need something that is going to document, it's going to capture every pertinent detail that like for the key problems that underlie a patient visit. All of the key pertinent positives and negatives in terms of signs and symptoms are going to be captured, that every single treatment step is going to be captured faithfully, that medications are going to be described correctly, dosages. And then on top of that, like problems have to be described in the right vocabulary, and they have to be grouped together, right? Like if you have it's not the same thing to have like diabetes and also have retinopathy as it is to have like a sort of like complicated case of diabetes associated with retinopathy, for example, like something like that like grouping together like a disease with a complication is different from like you have this disease and separately like you have this other problem. They're billed differently. One of them is a kind of compound condition that maps to a particular ICD code, which puts you in a certain risk adjustment category, which has ramifications for how like the hospital system might be reimbursed by Medicaid Advantage. There's a level of contextual awareness, both of like what's going on in the conversation, what are the exact documentation needs for clinical utility of those doctors, but also what are the documentation needs of all those downstream clerical processes, like the entire revenue cycle chain. And on top of, to make things like even worse, these are moving targets. For example, right now there's a tremendous amount of talk, especially in the context of administration change, about there being major changes to the key systems that underlie like how like Medicare reimbursements work. And so if those systems change, if the associated ontologies change, how documents need to be structured, what coders need to capture, and consequently upstream how notes need to be structured, might all sort of change in response. And so this is like a level of like a level of like vertical depth that you do not get out of off-the-shelf technology. So I would view like off-the-shelf tools, whether it's in the form of like open source models that you could fine-tune to your purposes, or even like third-party foundation models, things like GPT-4o, like Claude, like Gemini 2.5. As soon as this podcast airs, those numbers are all going to be outdated. I would view them not as solutions to these problems, but they're like, we're now in this very interesting landscape for like AI-based product development, where you have so many different weapons at your disposal. Like I'm trying to build a system that gives these doctors what they need. I can break down this task into, the following 15 steps, and each one of those steps, what's the right way to solve it? Is it going to be leveraging a call to a foundation model? Is it going to be training a model? Is it going to be, and very often it's like a ship of Theseus type construction, where maybe you stand up a new capability relying more heavily on some of the capabilities provided by a foundation model to build a system that you could put into production that meets a kind of minimum quality bar. And then you have a data flywheel that's ignited. And now you're learning from interaction. How are people editing what you're writing? Which in turn allows you to like distill a model that's better than the entire system you had previously, and you get to swap it out. So I think there's this incredibly dynamic environment, and the right way to think, I think, about those kind of foundation layer capabilities is not as solutions in and of themselves, but as like a key piece of like a weapon in your arsenal for solving components of the task that you have. I think it's not just us. I'm sure Cursor's doing the same thing, but like in their own world, they're not serving doctors, but they're serving software developers. But they probably have a very different chain of model calls that they're using for answering questions and doing like kind of like RAG QA off the code base versus what they're doing for code completion versus what they're doing for some other part of the workflow.
So it's helpful to think about it as these components that build the system that essentially gets rid of or makes these admin tasks much, much easier for doctors. One of the things that you mentioned is, are you actually doing the speech recognition part correctly? Are you detecting the right language? Are you dealing with the multiple people in the room, the very noisy conditions in the ER? And then once you have that, are you summarizing correctly? So both of those steps need to go. You need to do them well in order to get the ultimate output that you care about. And
yeah. And it's like, are you summarizing accurately? Are you capturing all the relevant details? Are you describing it in the language that's needed to support downstream clerical processes? Are you writing it in language that is digestible if the patient were to read the note? So all those things kind of need to happen at once.
Yeah, there's like a style transfer you need for each of these different stakeholders and each of these different, whether you're dealing with insurance, whether you're dealing with the patient, whether you're dealing with the doctor. But, what are the specific metrics that you use to assess the performance of, both the ASR system and then the downstream note generation?
Yeah, I think ASR is a lot more straightforward. It's not to say it's easy, but I think it's more straightforward than like note section generation. Just I think when you have the key difference is like, is there an unambiguous for each example, is there a relatively unambiguous ground truth, right? And for speech, again, I think you could get into the very fine detail and say, okay, certain things are a little bit ambiguous, like when people use stall words, like should you be saying or should you be saying or should you be saying But if you take that away, I think when it comes to speech, we'll have a lot of consensus over what is like the exact verbatim transcript that is correct and associated with that. Like there will be a little bit of discrepancy of, does someone think they know what the word is versus it inaudible, but you'll have very, very high inter-rater agreement on almost all of the content. And so at that case, you wind up in a more familiar evaluation regime for machine learning. Like you're tracking things like word error rate. We obviously want not just to track word error rate in a kind of overall sense, but we want to stratify in a lot of key ways. One, we want to distinguish between our word error rate on common speech versus on medical jargon. We want to distinguish between our performance across we want to have separate evals that can rate our performance in each language in which we kind of like advertise our system as being suitable. You don't want to have a system where you say you deploy the system, doctors are facing a very diverse population, people are thinking of it as multilingual, but actually like the performance in Spanish is like 10 times worse than it is in English. You want to kind of certify that you're hitting a high level of performance in all of the settings that you kind of for which you're recommending use of our system. When I say we certify performance in 28 languages, I don't mean that you can't speak those other 28 languages and have the system work. I'm saying those are the 28 languages where we've reached a level of diligence in our evaluation methodology that we feel comfortable putting our reputation behind and saying, hey, like Abridge is, like we stand by a recommendation that it's suitable for deployment in those 28. So a lot of the barrier to getting to like a longer tail, say closer to 100 languages, isn't just like building a better model, but it's just having the bandwidth to do the bandwidth and evaluation corpora to be able to provide that certification. So it's right. It's about accuracy. It's about accuracy on different subsets of the data, whether stratified by medical words versus common words, or on different languages or different types of conversations. We want to know that like we're doing well in like some of those noisier environments like emergency department, and not just doing well in the ambulatory setting, but actually you know, messing up, on higher noise environments. When you get to the more free text sections of notes, that's where it becomes a really, really challenging, but also like really interesting area, right? Because there's not a gold standard note that, like, it's like if you went to if you had the same conversation, you took 10 brilliant doctors from different places in the country, and you say, write the note that like you would have written, you're going to get 10 different notes.
I was going to ask Zach about something related, which is kind of how bespoke does this need to be to doctor versus you want to create a robust eval system where, to your point, there's not one golden standard. So I will insert that into the question, which is how customizable per hospital, per doctor, et cetera, do these notes need to be?
So there's like kind of like a fork in the conversation here where there are two routes we could go. I think the first is sort of like, how do we approach eval at all when you have free text notes? And then I think there's this other side that I think is a great question and I don't want to neglect, which is there's a fundamental tension in some ways between comprehensiveness of evaluation and level of personalization, right? Like if you have somehow made your model customizable in such a fundamental way, like if you say, oh, the model is fine-tuned separately, like the core model, anything could change, in response to each individual person's data. Like you have your own adapter, it's like the Oprah style. You get an adapter, you get an adapter, you get an adapter. The challenge is if effectively the models are so personalized and so different that from a statistical standpoint, you can't say a priori, you cannot guarantee that like any performance metric that holds for one user necessarily tells you what the accuracy will be for another user. Then you wind up in this thing of like, oh, well, if I have 100,000 doctors using my product, do I have to do 100,000 separate evals? And do I even have enough data from each individual doctor to support that? So that's one interesting issue, and maybe we could come back to, but at least we kind of tackled a little bit head on. I think the issue that comes upstream of that is just how do you even do eval at all for like you're generating a paragraph. I'll step back maybe one step to give a historical note here, which is to say that, whenever you're generating free text, even at a much more narrowly scoped scale, you always start running into this problem. I think a really illustrative example here is machine translation. When you talk about classifiers, generally there's consensus about like what is the positive class, what is the negative class, or if it's a multi-class problem, like which examples belong to which class. You have certain problems where there's very high inter-rater agreement, or there's some and we could just basically like automatically tabulate, like, did you get the right label, yes or no? And we could look at the confusion matrix in it. Maybe there's still some detail concealed because it's like, do you do different on different slices of the population? But the confusion matrix, like in the aggregate, tells the whole story. When it comes to machine translation, it's weird because, hey, there's multiple correct translations. And the particular correct translation that was sitting in the data set as the gold example as the label is not necessarily the one that the model output, but doesn't necessarily make what the model output wrong. And so then you wind up in this funny situation, which is like, well, what are you supposed to do? And so what did the community do? What we ended up doing was we basically had this two-pronged approach. On one hand, we're saying, hey, we need to try to come up with some kind of automated evaluation metric, because otherwise this is going to be a very expensive process. And at the same time, we need something to like guide the community. And at the same time, you run away from the like, there's not in the foreseeable future going to be a completely unambiguous metric of correctness, because if you truly had that, in some sense, you would have had to have like already solved translation in the first place. And so then you say like, well, you're going to have some amount of reliance on checking in with human like determination, human expert determinations of quality. And so you have this kind of parallel process of basically people developing metrics. They propose Rouge score, like Bliss score, Rouge score, Meteor score, all these different variants of metrics that attempt to capture some coarse measure of like okay, maybe not every single output will exactly coincide with what was the label. But you could have a coarse metric of like, well, how much overlap was there? They do these different things. Like they say, what was the amount of like, what was the 1 gram precision, 2 gram precision, 3 gram precision, 4 gram precision? They average these things. They add a brevity penalty, and you come up with these heuristic measures of quality. And then you say, well, how do I know that this is a good thing, that the community should be chasing these? And what you end up doing is they do human studies, and they have some automated eval taking place, but also there's a community focused on eval that is actually periodically doing these studies where they would look and they would say, let's take, the top 10 translation systems, rank them according to their, whatever score was, their Rouge score, Meteor score, but also send a whole bunch of examples to human translators, professional translators whose job is to make quality judgments. And we say, well, what was the sort of order of, what was the sort of stack ranking according to the humans? What was according to the metric? And if despite that metric being in use for a while and people continuing to guide the research community to improve on those metrics continue to sort of faithfully reflect like the stack ranking over systems, then we gain a little bit of faith that those metrics are doing a good job. I'd say at Abridge, now the problem is way more complicated because like little like n-gram overlap kind of measures don't really work because we're talking about paragraphs or pages, not about individual sentences, just single sentence translation. But the general principle applies that you have this like two-pronged approach. On one hand, you're innovating really rapidly on building a kind of automated eval sensory apparatus that can look at notes that are generated, that can look at gold standard notes, and it could give you metrics.
Be really specific for the gold standard notes. Are those notes that already exist in the system that are
sure? And again, I think you can have metrics that look at gold standard notes. You could have certain metrics depending on what it is that you're trying to measure that don't necessarily even look at a gold standard metric, but there may be like targeting something like factuality, going claim by claim and trying to give you an output of is there adequate support for this claim, in the transcript. Obviously, if the metric becomes good enough, then you say, oh, it shouldn't just be a metric, it should be part of the system, and I should use it as a guardrail. But you build a sort of collection of these systems for evaluating your system in terms of quality, in terms of comprehensiveness, et cetera, that are useful for guiding the development process. But you can't get away from the fact that at the end of the day, there's a human judgment about quality, and you're producing too complicated an object, and there's not like a single LLM as judge that could take away right now the role of human judgment. So what we have is like, we have an automated eval sensory apparatus. It helps to guide us in the development process. It helps to monitor models in production. But at the end of the day, we don't ship anything into production. Like, we're not going to ship like, hey, we've reworked the entire engine that generates, the history of present illness that is being written for, millions of patients across the health system, and we're going to throw it into the wild blind without human eyes. So what we basically do is we use our automated evals to guide development. But once we have a candidate system that we think is in decent shape, we subject it to what we call an LFD. It's affectionate term, stands for look at the fucking data. And in this process, we have built an internal platform for doing blind evaluations. So you'll have a system in which there's the transcript present, but there's also the output of like the status quo system and the output of the candidate system that is the, putative improvement that we're contemplating shipping. But they're presented in a random order and they're blinded. So the person who's doing the review doesn't know which system they're evaluating. And then we capture a lot of details here. We capture preference.
The person doing this then is the doctor, for example, and you're like, here are two potential options, or who is the end?
So we have a workforce of clinical experts. And right. So we have actual like clinicians, people with clinical backgrounds who are reviewing these notes. And the challenge is that they're reviewing two different notes against the same encounter, but they weren't part of that encounter. They weren't sitting in the room with a patient for the 30 minutes. They don't have all the context. So, there's a challenge of the easy thing to do is to look at the notes and say, is the note structured well? Is it written well?
Does it actually capture the nuance?
Right. Well, that is the nuance. Like, is it accurate? Like, how do you know that something is real versus confabulated? And to support the analysis, what we've done is we developed a tool for surfacing linked evidence. So basically, when someone's and this is a tool that's part of the product that the doctors see for when they're trying to verify things, but it's also part of the evaluation methodology that when you're reviewing the note, you can highlight any word or phrase or sentence in the generated note. And what will happen in the interface is you're going to float to exactly like where is the highlighted region of text that supports that claim. And so that makes it very easy to verify, like you see the patient says they're taking 8 milligrams a day of Flomax or something. I don't know. This person apparently has a urinary issue. And I read a lot of clinical notes. And so you highlight this, if you float immediately to that part of the conversation and the doctor is saying, so you're still taking 8 milligrams of Flomax? And the patient says, yeah, you don't have to read, you don't have to fish through 20,000 words in order to say, okay, I believe it. The claim is correct.
And that makes sense. You basically want citations, and you want to know, am I looking at this thing? Is it trustworthy? Also, if I'm looking at these two different things, this just saves and reduces my time tremendously.
100%. And same for the doctors. Sometimes we actually have these things where sometimes the doctor sees something in the note. I had this a long time ago. A friend, one of the earliest memories of this feature really working was I have a doctor friend who is a friend of the company, is also a user of Abridge and gives us great feedback. And he calls me up and he's like, I think the model hallucinated. And I said, what happened? And he said, well, sciatica showed up in the patient history. And the patient was like in the emergency room for like heart failure. And it's like, sort of like, he's looking, he's like, why the hell are you talking about sciatica? Like, this is a heart patient. And so I was like, well, did you try highlighting it? And so if he highlights it, it actually floated to a point in the conversation where the patient mentions their sciatica. And, it doesn't just float to the region of the transcript. If you click on that region of the transcript, you hear the audio playback that comes from that exact moment in time. And so this was a case of like the patient mentions it. The doctor kind of like tuned it out because it, didn't feel like a super relevant detail to like they're trying to, deal with the acute problem. But it just kind of like went one ear out the other. So yeah, it's a great feature because, I think we worry a lot about AI systems hallucinating or confabulating, as we should. But I think one thing that we forget about is like there's also a certain amount of human fallibility. And, ideal situation here is that we get the best of both worlds, that, we get a system that is very accurate, that doesn't make errors, but also that helps sort of do some error correction on the human side, that we catch details we might have otherwise forgotten.
Some of what you mentioned is actually just, you have to create the systems. You need the clinical partners, labelers who will tell you what looks like a better note. And then some of it is potentially touching more on model building research. So how do you do really good citations, for example, in the SOAP notes like you talked about? So you hold these two titles, CTO and CSO. Like, how do those organizations coexist under you? I'll quote you because I saw that you tweeted recently that a CTO is a slippery title. So it could be a technical founder that doesn't want to manage, is now an IC engineer, it could be a VP of engineering, could be leading all of end product design, or an influencer with no internal responsibilities. So what kind of CTO are you?
TLDR is, and I think, I think my like weird like title collection is really just like a trail, like kind of maybe a history. Like I think it's like an artifact of like how I started off as a scientific advisor. So I was like a founding advisor of the company. I was supporting the company, like I was in Shiv's ear, but I wasn't in the day-to-day of like process at the company. I was also I'm a professor at Carnegie Mellon. My lab was collaborating with Abridge. UPMC was investing in the company. They also had funded my lab and they were encouraging us to collaborate. So we were working on that side. So I was like an advisor and research collaborator. That was like my initial role. When I stepped into the day-to-day, I stepped into it as a chief scientist. It was like my job was like machine learning rolls up to me, and machine learning, but not like the app engineering. I think what ended up happening was I had I think that like applied science, I think we don't think of ourselves as being in product development if you're like living in a university because you don't know anything about that. But there's something about applied science that's very much like, I think aspirationally, like sci-fi product development, because you're doing a lot of these routines. Like when you write a paper, you're kind of trying to motivate, like, this is an important problem to these people, we should be building a system that could do X. Like you're doing the work that like essentially is like product discovery. Then you're like also doing the work. It's just that you're like a team of 3 people. So you're wearing all the hats. You don't think about like, I'm a product manager. Now I'm an engineer. Now I'm a scientist. Now I'm a marketer. You're just thinking like, I'm trying to identify an important problem, come up with a solution, build it, analyze it, do some math along the way, write it up in a compelling paper, present it to my community. You don't think I'm a product developer, now a product manager. Now I'm an engineer. Now I'm a scientist. Now I'm a marketer. Now I'm a business person. And so I think I just came into the scientist role naive about where do my responsibilities end and other people's begin, because I'm very much like, I wasn't coming at it like I have a phenotype. I'm sitting in an org. This is my lane. I came at it very much more from a like, I don't know, like founder vibes, like I want to build shit. I want to build cool shit that's useful to people. Are we building the right thing? Are we shipping it? Could we ship it faster? Does it look good? Is it great to play with? I don't want us to die on human interaction. I don't want us to die on design. I don't want us to die on customer relations. I don't want us to die on engineering execution. I don't want us to die on model performance. And so I think it was kind of one of these things of like the role just kind of like, just by virtue of like maybe like me being like not having a sense of boundaries or like where my job should end, it kind of like grew to like subsume what we call the wider builder organization. So like what rolls up to me is actually all of science, engineering, product, and design. I have very strong leaders in those units. Like I have a chief product officer who oversees product management, design, and like product intelligence. I have 2 VPs of engineering, one for like foundations, like cloud architecture, backend systems, data engineering, security, IT. I have one on a VP of product engineering, and then I run the AI org closer to the ground, with some very strong kind of like player coach scientists and ML engineers and clinician scientists. But part of my perspective on this is, I guess, like one, I don't know. I think a lot of my research agenda has been like, I want to build products. Like I want to build something that has an impact in healthcare. Like that's why I got into PhD. And I think with a purely like academic cone, there's a limit to, I think things usually end with like, we have a cool proof of concept and there's a paper, and then it kind of like dies. And
yeah, you're not building the thing in the hospitals.
Right, like the doctors aren't actually using the model. It's like it's sitting on the floor and hopefully it influenced somebody. And I think that was always like a bucket list item for me to like actually get to have that impact. And I think when I got a taste of it, I maybe like wanted it all. I think there's also another key part of the story is that I think, and this is something that I've been on about a lot recently, is that I think like AI product development is like a new thing. It is like there's a very mature software product development playbook. Like there exist playbooks for like how to, it doesn't mean everyone does it exactly the same or at the same level, but there's playbooks, there's archetypes. It's like when you watch like an NFL game, you're like, oh, they're running like, like I recognize the 4-3 defense or something. Like it's one of the plays I've seen before of like how product management and engineering management, design, and product engineering and infrastructure engineering coalesce to build a software product. This other side of like where there's a dynamic of like interaction design decisions influence what data you get, influences what you could do on the modeling side, influences both how you can improve the current product and like what new features you could build in power, where like sometimes ideas come from ML, sometimes ideas come from customers, sometimes ideas come from like, from like product intel. I think that like this new world is very like, it's sort of like, to me, where my mindset is right now, it is like, what is interesting? It is the most exciting thing in AI is that like, it's like, it used to be the most exciting thing was like the architectures or something. It used to be the most exciting thing was the math. And the most exciting thing was like the architectures and we could achieve. Now I think a huge part of what's so exciting is like the ecosystem, the way that like there's this direct line, like so much of what OpenAI has done that's so innovative is not like just that their models are better or like their algorithms are better, was that they really closed this loop in a very powerful way.
Yeah, the research impacts the product, and then the product makes the model better.
Yeah, like ChatGPT to have this like huge trove of conversations, which is tied into like a massive like data labeling and like, kind of like output rewriting, like industry, which is fueling product development. And so that tie between what you ship and how you and what you could do on the modeling side is what's so interesting. I mean, the other thing I'll add is that just like I think AI in industry, like for most of my time between like starting PhD and becoming a professor, like 2014 until a couple of years ago, most like AI industry was a very like siloed. It was like there's the research org that knows shit all about how to build a product.
I was going to ask, how do you hire researchers who care about the product, and how do you hire product that cares about AI? I mean, finish your thought, but if you need all of these to mesh together, how do you get them either structurally or through the door?
I mean, so much of that is just being willing to have a filter.
Yeah.
You know what I mean? Like, I think like that's like a general like truism of hiring. There's a level of like when you're like green at something, like that level of like when you're whether it's like you're job seeking or hiring, where like you recognize someone is good. And so you'll say whatever it takes to get them, or like you recognize an opportunity is a big opportunity. So you'll say whatever it takes to get it. You know what I mean? Like you want the job and they're like you want to do front engineering, but they're like, we need a back end engineer. Like I could do back engineering too, or something, or like, like it's like research. I want to be in a lab that does theory. And they're like, well, we build systems. And you're like, well, I can also build systems or something. And, I think there's this level, which is like, and obviously it requires some security or some confidence, ideally a combination of the two. But like where you say like, hey, like there's a lot of opportunities in the world. They're not all for me. There's a lot of potential PhD students in the world. Some of them are going to be amazing, but they'll be amazing in someone else's lab. They don't have to work with me. And so you could like set a filter and say like, what I want, like this is what I want to go after. And I'm willing to pass on someone amazing who isn't aligned. It's like if they really want to do something else, it's okay. They can go work with someone else. And so I think it's the same thing with a company. It's being willing to say like, hey, if there's an amazing researcher out there and like they're not excited about building in healthcare, it's like easy questions like why Abridge? Like why do you want to come to Abridge and not go after an academic position? Why do you want to come to Abridge and not go work at like OpenAI or Anthropic? Like, like what like like why are you into it? And if someone's like, like a test for me is like if it feels like someone would just as happily work for us or work for Microsoft, I'll encourage them. It's like, go to Microsoft. Like you're going to have a great life. If you'd be happy there, if you'd be happy with that intensity level, if you'd be happy building like, if you'd be happy building like an AI product for like, expense reporting, it's like I love Ramp. Like Ramp has made my life better. It's awesome. But I don't want to work there because it's not the problem I'm excited about. You know what I mean? So I think both about like, are you excited about product? And also, are you excited about like this product? Are you excited about like this opportunity to, and I think there's a whole bunch of people who've cared about machine learning for healthcare. They've been, people who can publish at NeurIPS and ICML and ICLR, but they've been showing up at the weird meetups, at the, MuckMeds, at the MLHCs, at the chills. Because like they're trying to get close, like they're machine learning people, but like their dream is like, hey, like we should be able to do something. We should be able to do more in healthcare. And like, that's the impact that they want to have. And like, those are the people that I want. Like, that's the team I'm trying to build.
Yeah. So you filter on essentially on the research side, researchers who actually care about product and they don't want to publish papers in isolation, and researchers who say, Abridge, this is close to a life mission or something that I would really, really want to devote years to because I give a fuck. Okay. We are definitely short on time. I'll just ask you one more question. We talked about some of how conversation is this fundamental data source that lets you do all of these other things. And so I'm curious what you think is the biggest opportunity moving forward in healthcare and AI, whether it's, access to other types of data that let you do more things, or shifts in research. What are you most excited about going forward?
I'm really excited about connecting dots. Like, I think that there's a lot of AI components that are plugging in here and there. in isolation. And I think that there's just there's a bigger tapestry here. It's not just I think like outpatient visits are like a great place to land because you're like one interaction with one doctor having one conversation, yields one note, and then like you can kind of like be done. And if you get that right, it's a huge amount of value. So it's an amazing problem to go after. There's still so much work to be done on it. But if you look beyond now, you're like, okay, like we can handle like how do we start connecting the dots on the patient history? What about emergency departments, inpatient settings where actually it's like, you have not one conversation or one touch point, but in interactions with many different providers over hours or days. When you're in this world where like you're producing, like how do you start getting inside all these different parts of the workflow? Like, there's a handoff from one provider to another. What context does that new person have coming in about what was said previously? When you write the note at the end of the day, can we connect the dots between the conversation they had with the nurse and the resident and the fellow and the attending and the technician? Can we connect what's happening in the clinical conversations with what's going on in the rev cycle part of the house? Can we start pulling in information about standard, kind of things like standard of care instead of doctors like offline doing their research? We have a recent partnership that we announced with UpToDate that we're super excited about. But can we get this world where we're providing medical education, not just like separately at home or like between visits, but actually like doing all these things at the point of care, at the moment that you need the knowledge, surfacing it. And so I think that there is just this incredible opportunity to, I think it's just like you used to see before. I had one model to do translation, one model to do one service for search, one model for something else. And instead you're starting to find that like, hey, with multimodal models, with longer context lines, you're able to have these very different kinds of experiences, like for a consumer interacting with, say, ChatGPT, than how you used to touch these more a la carte sort of single purpose models. I think there's this opportunity to weave together a much more cohesive experience that spans multiple stakeholders, that spans the entire workflow, and that spans different modalities of data. And I think that's like this huge opportunity for us to I think there's a world where we build a kind of balkanized set of point solutions, and there's a world where we invent like the AI layer for healthcare. And I think there's an opportunity to go kind of more boldly for that latter vision.
I love it. Well, thank you, Zach, so much. Appreciate the time, and I always learn from you. So really, really appreciate it.
Yeah, you should come by the office. We'll host you for lunch sometime.
I'll come
or
hang out.
breakfast.
Thanks, Zach.
Awesome.